We're going to start exercise 5C. Python is a programming language that in the GIS context is used to script geoprocessing workflows and build custom geoprocessing tools. So we can type Python commands from the Python window command line in ArcGIS Pro, which is right here. You can also install Python for ArcGIS Pro to run Python commands and scripts. Outside the application, ArcPy is the name of the Python side package that enables you to run ArcGIS commands from Python. So if the idea of writing code does not appear to you, don't worry. A full synopsis of Python and coding techniques is far beyond the scope of this videos. Later, I might do one. Think of this exercise as a first look at the Python window in ArcGIS Pro. Sometimes you may want to explore in depth later. So even if you are well schooled in the world of coding, this might be helpful to see how Python can be incorporated into ArcGIS Pro, which I did maybe 2 to 3 weeks for Python studying. So we're going to create a new ACLED layer using a limited feature definition and meaningful symbology. We're going to use a geoprocessing tool and then Python code to do the following. Create a layer file from the new map layer, and we're going to use a custom script tool to do the following. Select only those conflicts classified as violence against civilians. Summarize the number of fatalities within the selected set of features. We're going to define the data. Before we jump into we still continue working in this conflict project. It should contain 2 ACLED layers, so that we have Sudan and Rwanda. So now I'm going to, this is Rwanda, and then we have Sudan and Rwanda, and we're going to drag this down. So, and if we have everything and we're going to add another copy of these 2000, this one, Africa, but we already did definition query. We can just go back and definition query. We can just clear it, clear. Click OK. And then there we have everything for that layer. Limit layer definition to the county, and we're going to do Nigeria. So we're going to move this on top and right click on it. We don't go back to this add clause. This field will be country equals Nigeria and then year greater than equal to 2013. So we will have country equal to Nigeria. Start with N, Nigeria, and click add, and then we add a clause, and we have year greater and equal to 2003. Click add and click OK. Alright, so then we have that, and we're going to rename this layer 2003 and 2000 this. Going to property and general, it will be Nigeria, and we're going to click OK. Alright, this is Nigeria. Perfect. Okay. And then we're going to symbolize that graduated simple map. And we're going to expand it. Oh, it's already there. Graduated symbol map property and symbology. It didn't go have symbology here anymore. Wait. Alright. We go to appearance symbology. It's right here. Graduated symbol. Graduated color map. And then we're going to do is fatality again. Let's see, based on fatality fields. Yeah, fatality, natural, and then classes. We're going to do is 5. All right. This is graduate color, graduate symbol, and fatality, and then 5. Okay. There, and then use the default classification and symbols, alright? Okay, now right click on it. No, symbology. Symbology is right here. I'm going to see. Oh, it's not here. Symbology. Not from here. Alright. Alright, so now we're going to execute a command using Python right now. We're going to create a layer file to store the definition query name and a symbology scheme of this layer. Then it can be used in other maps or projects without having to repeat the preceding steps. Layer files also save label characteristics and custom layer pop-up window. If applicable, you will first execute this command using the save to layer file geoprocessing tool, and then again using copy Python code, and a third time by entering the code yourself. And then on the analysis tab, so we're gonna go to analysis tab and the Python window, and click the tool button to open the geoprocessing. And then we're going to enter save and save layer file. Save layer file. And the tool parameter requires an input of layer and then output of file name and an option setting to save the file using a relative path. Using this option means that if you move the layer file to another location, its path to the source data is updated accordingly. And set the following tool parameter, and then we're going to click Run. So input layer, it will be Nigeria, and then output layer, it's a layer. And then store relative path. That's very important. Click that. So we select the checkbox to store relative path, and this perfect. And we're going to click Run. When the tool is finished running, we're going to take a moment to save the project. Okay, perfect, and it says it completed successfully. And we're going to go to project and click save, and we're going to right click on the status bar. Okay, alright, click yes. Oh no, and then I have to bring my history back. Alright, save to this and right click on it and copy. Oh, where did it go? And I copy Python command, and then we already copy it, so that we close that. We can just copy the command from history in the Arc catalog. And usually the geoprocessing in ArcMap, they have a result, but here we can just go to history. So, and then we back in the Python window, which we already have it ready. So in this step, we're going to docked in several locations or just let it float. But here it says enter Python code here. We at the bottom of the Python pane, we're going to right click the code and then click paste. And then all geoprocessing tools are accessible from ArcPy. If we have a workflow that uses 10 geoprocessing tools, we can write 10 lines of code with one line calling each tool. So we're going to click at the end of the copy code to see a copy parameter description pop-up message. So save that. It's right here. Just like the geoprocessing tool, the Python code parameter expects you to enter an input layer and output layer. So optionally, you can enter a parameter to see to set the relative path option and choose which version of the data to use. That multiple versions exist. Optional parameters are marked with curly brackets, and then in description pop-up message. So if you run the code as is, the operation will fail because there is already a layer file in the conflict folder called ACLED_2003_2013_Nigeria. Layer file, the one you just created from the geoprocessing pane. In the Python window, we're going to change the output name to the Nigeria 2. Alright. File name Nigeria, and then we're going to do, it's saved T and then 2. Earlier I didn't change it, and then just type and then relative current. The code is a little different. And then again, we click at the end of the code, and then we're going to click enter so that the result it gave us. So now let's see what's happened here. Then we go to folder, and then there, that's our layer file. Now you will run to save to layer tool a third time, but this time we're going to enter the code manually. So we're going to clear the history in the Python window. We can just right click the upper portion of the window and then click clear transcript. So right click, clear transcript, right? So then we begin to type argpy dot save to layer file. And notice the Python pane offers the correct entry when you begin typing. So and argpy dot something to layer file, and then we click the autocomplete suggestion to call the tool. So notice the highlighted pair parenthesis after the tool and the toolbox name. The spot is where you add your tool parameter. So now we're going to practice a little bit. Oh, the path name is a little bit more here. So the following steps are optional, so at least we're going to go over it together. I'm new here as well. I learned a little Python, but not enough. So in the entry code, we're going to do type import argpy first. Import argpy, and we're going to hit enter. That the line code is added to the upper portion of the Python window. This line is matter of protocol. Within ArcGIS applications, it is not required. But if you want to run Python commands outside ArcGIS, it is required. So it is a good habit to get into. So import argpy. And then next, we're going to set the environment to ensure that the operations output will be stored where you want it. Again, this step is optional because you are already in the workplace you are calling. So we're going to work in a different project or environment that is required. We're going to type argpy dot environment and then dot work space equals that I have to get quotation mark, and my path, I have to find my path. So it's not in C anymore. I wish I put it in C, conflict, and then I need to find my path. So how do I find my path?